Picture this, an event so powerful it can outshine every star in the observable universe combined, yet it happens in complete darkness, completely invisible to our eyes. What you just imagined is real, and it's happening right now across the cosmos. We're talking about binary black holes, the universe's most destructive dance partners locked in a gravitational embrace that ends in catastrophic violence. These aren't your ordinary black holes lurking alone in space. Binary black holes come in pairs, dancing around each other at unimaginable speeds, getting closer and closer until they finally collide in the most energetic events since the Big Bang itself. So how does this cosmic tango begin? It starts with massive stars. Many stars are born in binary systems, two stars orbiting each other. When these massive stars reach the end of their lives, they explode as supernovae and collapse into black holes. If the system survives this violent transformation, you get two black holes circling each other, beginning a dance that can last for billions of years. But here's where things get really interesting. As these black holes orbit, they don't just move through space, they actually warp the fabric of spacetime itself. Einstein predicted this over a century ago with his theory of general relativity. Massive objects like black holes create ripples in spacetime called gravitational waves. Think of it like dropping two heavy stones into a pond and watching the ripples interact. Except in this case, the pond is the fabric of the universe, and the stones are each millions of times more massive than our sun. These gravitational waves carry energy away from the system, causing the black holes to slowly spiral inward. Their dance becomes increasingly frantic as they get closer. What starts as a slow waltz over millions of years becomes a frenzied spin in the final moments. The black holes can reach speeds approaching half the speed of light as they circle each other hundreds of times per second. The final merger is where the real cosmic fireworks happen. When two black holes finally collide, they release more energy in gravitational waves than all the stars in the observable universe combined emit in light. This energy isn't in the form of explosions or light we can see, it's pure spacetime distortion rippling outward at the speed of light. In 2015, scientists at LIGO made the first direct detection of these gravitational waves from a binary black hole merger. The signal lasted just 0.2 of a second, but in that brief moment, it confirmed Einstein's century-old prediction and opened an entirely new way of observing the universe after the merger. The resulting single black hole typically gets a massive kick, sending it flying through space at incredible speeds. Sometimes this kick is so powerful that the black hole can escape its host galaxy entirely, becoming a rogue black hole wandering the intergalactic void. But why should we care about events happening millions of light years away? Because studying binary black holes helps us understand fundamental physics in extreme conditions we could never recreate on Earth. They're testing grounds for general relativity, probes of black hole formation, and windows into the early universe. Recent observations suggest binary black holes might be much more common than we ever imagined. Some estimates suggest there could be millions of these cosmic dance pairs in our galaxy alone, each destined for eventual collision. The next generation of gravitational wave detectors will be sensitive enough to potentially detect these mergers daily, giving us an unprecedented view of the dark, violent side of our universe. So while we look up at the night sky seeing only stars and galaxies, remember that some of the most spectacular events are happening in complete darkness, detectable only through the subtle ripples they create in the very fabric of reality. What's the most mind-blowing space phenomenon you've ever learned about? Share your cosmic wonder in the comments.